Hello, this video is parametric equations and points of intersection. So here's our first question. The diagram shows a curve C with parametric equation x equals at squared add t, y equals a, open bracket, t cubed plus 8, where t is a member of the set of real numbers, where a is a non-zero constant. Given that c passes through the point -4, 0, which is here, find the value of a. So, to start with, I am given a coordinate, and this is an x value and this is a y value. So I could use these values in these equations. So I'm going to take for part A my -4, 0 coordinate, and from that I can write that -4 equals at squared add t, and I can also write that 0, because that's the y part of the coordinate, equals a t cubed add 8. Now, if I can find either of the t values, that will help me then find the a value. So from the equations, if I number them, I'll number that one 1 and that one 2, I'm going to take number 2, because if I then, having taken that, if I know that a is a constant, so if I divide by a constant, I'm not losing, that's fine. It's when I've talked before about dividing by a variable like t, you will lose solutions. So we don't divide by that variable on both sides. But here, the a here is a constant. It says that here. So I can divide both sides by a, and I end up with 0 equals t cubed add 8. Therefore, -8 would equal t cubed, and that gives me that t is equal to -2, and there's my answer for t. Now that hasn't given me my value for a, but having got that value for t, I can then put that back into my equation to find what a is. So if I now look at equation 1, which, if you remember, is this, so looking back up at equation 1 at the top, that's that, then -4 equals a multiplied by -2 squared at -2. Keeping going, that would be 4a subtract 2. So -2 is equal to 4a, because I've now added 2 to both sides. So a equals -2 over 4, which, as you know, would just be -1/2. So you've actually found out what a is, and that's it, done. Just check your question that you have done everything you were asked. So looking here, it says find the value of a, and that's exactly what I've done, so that's all good. We can now look at part B. So part B says find the coordinates of the points A and B, so that's these here, where the curve crosses the y-axis. So we're talking where they cut the y-axis. So if I think about this, and I'm going to go over here for B, if you're going to cut the y-axis, that means that x equals 0. So I know that x equals a t squared plus t, and I know that a is negative a half, so I can say that now 0, because x is 0, equals negative a half t squared add t. Just to remind you, x is 0, that's 0. A we calculated in part A was negative a half. Carrying on, we then say, here we're factorising. And I know this will be obvious for some of you, but I just want to point this out because it's an error that I see A-level students do. If I go back over here, I divided both sides by A, and I mentioned at the time that's fine because it's a constant. A is a constant. Here, this is where people go wrong. They're going to divide through by t. We don't divide through by t. If we divide through by t, because it's a variable, we're going to lose a solution. So yes, divide by a constant, that's fine. Here, don't divide through by t. We will lose one of our answers. So now carrying on, the way to solve this, if you remember back, it's good old factorising. There we go. So from that, I get t equals 0 or minus, if I just go back up here, because I forgot to put the 1 in, I think that's where I drew the bracket, I got confused. So that's 1, a bit of a thick one now. So back to here, sorry, this would be negative a half t plus 1 equals 0, which if I then rearrange that, I would then end up with t equals 2. So there's my two solutions. If I had divided through by t, I would have lost my t equals 0, which would mean I wouldn't have got two solutions here. I'd have only got one. So be aware of that. Only divide through by a constant all the way across an equation. Don't do it with a variable. So I've now got the t values, and if we just go back to this here, it wants me to find the coordinates. Well, I know the x value of the coordinates, I'm trying to find the y. So I'm going to have to substitute back into y. So just remembering here, y equals, the actual equation from the top is a t cubed add 8. Notice I rewrite it. I rewrite it because I've had to keep scrolling up and down. Now in an exam paper you could have turned the page, so write it out. Just take that extra moment, check it's right, as it's a commonplace again where you can lose a mark, and it's not losing a mark because you can't do it, it's using a mark from a silly mistake, and we don't want those. So y equals minus a half, because that's the value of a, of, I'm going to put t equals 0 in to start with. 0 cubed, add 8, so y would equal negative 4. So the first coordinate would be 0 because we know x is 0 and y is negative 4. The other value is when t equals 2. So y equals negative a half of 2 cubed add 8. So that would be y equals negative 8. So my coordinate is 0, negative 8. I think that's everything done now. Underline my answers, make sure they stand out so I can see them as well. Check back. Find the coordinates of the points A and B, where the curve crosses the y-axis. Yep, that's it. Done. So I think it's now one more example of these, just so that we definitely have got this, and notice this one's with trig. And it's just a way they can, because some students don't particularly enjoy trig, if they put a trig question, for them they see it as a way of challenging you a different way. So let's read through this question. The diagram shows a curve C with parametric equations x equals cos t plus sine t and y equals t subtract pi over 6 all squared. Find the point where the curve intersects the line y equals pi squared. Now, this is just simultaneous equations. If you think about it, if something's going to intersect, it's where they're at the same point at the same time. And therefore, the y value here must equal the y value there. That's what intersection means. And it's just simultaneous equations, but via substitution. So if I look at part A, what I can do is take these two pieces of information about y and this one here, and because we're saying point of intersection, they're going to be there together, we're looking at this. Now, you want to square root, but you've got to remember, if you square root, then you get a positive and a negative value. So therefore, I'm going to put the t minus pi over 6 over here just because I prefer it. And that would equal plus or minus pi. Okay, so you've got to remember that when you square root, you get that positive and that negative answer, because if you get that, again, you lose some solutions, which they're checking. Are you aware of that in the exam? It's another way they check your whether you do fully understand all the mathematical concepts. So, having got that, we then can say, well, t equals, we're adding pi over 6 on, so it'd be 7 pi over 6, or negative 5 pi over 6. Great, done. Let's go back and check. Oh, hang on a moment. Don't think that is quite done. Why, you're saying? Well, look at this here. My t values, if I put a little box around them because they're now looking rather important, I can only go from negative pi over 2 here, whereas I've got negative 5 pi over 6. This here is half pi. This is nearly a whole pi. This one isn't possible. Now let's just check this one is possible. 7 pi over 6. Well, 7 pi over 6. Let's make the denominators the same. That's 12 pi over, 8 pi over 6. If I times the top and bottom by 2. So that one's fine, but this one isn't. So I do need to make a comment about that. So I'm going to say outside the domain. Because it's domain, remember, functions, they are the input values, is a way of thinking about them. So the final answer would just be t equals 7 pi over 6. So that is part A done. So I'm going to scroll back up. Always just check you have fully answered the question. So find the point. Find the point, not find the t value. What did I just do? I found the t value. I need to find the point. So I need to find my x value and I need to find my y value. I know what my y value is. It's y squared. So I'm going to need to put my value for t into x equals cos t plus sine t. So I need to just go back. So x equals cos t plus sine t. So here t equals 7 pi over 6. So x equals the cos of 7 pi over 6 plus the sine of 7 pi over 6. And if I type that in my calculator, I'm going to get negative 1 plus root 3 over 2. So my final coordinate, comma, pi squared. And remember, the pi squared came from the question because they told you what the value of y is. Now, hopefully, now I definitely have answered that question because I hadn't previously. And that's why you should go back and check because sometimes at the end of a long question, it's easy to get to a point and think you finished, but you actually haven't. So, have I? Yes, I've definitely answered it now, which is fantastic. Now, find the coordinates of A and B where the curve cuts the y-axis. So if we're looking at where it cuts the y-axis, this is when x equals 0. So I'm just going to move over here a little bit, give myself some more space, perhaps shrink the page a little bit as well. So for x equals cos t add sine t, we're now going to say 0 equals, because we're doing, this is part B, and it's when x equals 0, cos t plus sine t. So sine t equals negative cos t. So tan t equals negative 1. So if tan t equals negative 1, this is where you now need to think of your tan graphs. So let's think about negative 1. Negative 1 is here. Negative 1 would also be here. So if we think of our values, t would equal negative pi over 4. And then if you remember, tan repeats every pi radians or every 180 degrees. So this would be an add pi on or add 180 degrees on. So this would be at 3 pi over 4. But we need to think of that domain. Are they both within the domain? Let's go up and check. Well, negative pi over 4, yes, that's closer to 0 than negative pi over 2. So yes, that's going to be in the domain. And 4 pi over 3, well, that's definitely more than that. So both of those are definitely going to be within our domain, and we can use both of those therefore. So we now, because remember the question's asking the coordinates of point A and point B. So here we go. When t equals negative pi over 4, we want to find out what y is. Now remember, from the question, y equals, I'm going to just write that here, y equals t minus pi over 6 all squared. So here y equals negative pi over 4 minus negative pi over 6. Might want to use your calculator for that. Remember, you can just type in negative 1/4 minus 1/6. You don't have to put the pi in as well. That would give you 25 pi squared over 144. So here, that would be my first coordinate. And the next one was when t equals negative, oh no, it's positive, isn't it? 3 pi over 4. So y equals, substituting it in just the same and if you substitute that in, it's equal to 49n squared over 144. So the coordinate, oh, that's my last answer, not underlined, 0, 49. That looked like an n, and it should be a pi. I think I even said n, that's why I did it. There we go. There's our two coordinates, and that's that question answered as well. So really, this isn't that much different to many things you've done before at GCSE. The difference is this third variable that you're reliant on. And you've just got to be more confident with your substitution because the functions that you're substituting in aren't going to be quite as simple. But other than that, the maths is just taking your GCSE and using it in a different way. Challenging, I don't disagree, but there's not lots of new things to learn here, thankfully.